In learning 28 days, today I am going to discuss a very simple but very important topic in power electronics, and many times the questions has been asked from this topic in previous gate examination. Let us start our discussion. In this, we are going to study the behavior of power electronic switches, and these behaviors have been classified in three broad categories. And this was the first classification that we are going to study. In this classification, we will study the behavior of switches based on their controllability. Means whether we can control the switch or not. That is, we are going to discuss in this topic. First comes uncontrolled switches. In these switches, we don't have any control in turning on and turning off. So we don't have any control on this type of switches. So we cannot control its turn on as well as its turn off. It will turn on based on the nature of supply and nature of load. Example of this type of switch is diode. In the diode, we don't have any control. For example, we consider it as diode. This is its power terminal, anode and cathode. It doesn't have any third terminal where we can control its operation. There is no third terminal through which we can control its turn on and turn off. It will be turn on and turn off based on the nature of circuit. Suppose AC supply is there. So whenever the diode is forward bias, it will conduct. When the diode is reverse bias, it will not conduct. So its turning on and off depends on the nature of supply. And the second condition is the nature of load. Load means if in the diode circuit, if inductive load is there, then due to stored electrical energy in inductor, diode conducts even after 180 degree. That is, it will conduct in this cycle as well as to the some extent in the negative cycle also. But how far it will conduct, it will be decided on the inductance value in the load or in the circuit. So this is the first, that is uncontrolled switch. Now second, that is semi-controlled switches. In this type of switches, we have control on either of the two states. That is, either we can control turn on or turn off, but not both. Okay, for example of this type of switches is SCR. In SCR, we have three terminals: anode, cathode. This is gate. Through gate, we can control its turn on and turn off. Okay, this is the power terminal, anode and cathode. So after the turn on and turn off, we have control in only one type, that is turn on or turn off. In SCR, we can control only turn on, not turn off. Next type is fully controlled. In this type of switches, we have control on both turn on and turn off. Example, GTO, gate turn off thyristor. Transistors, that is BJT, FET, IGBT. Okay, so this is the first type of classification that we have seen now, where we have seen three types of switches: uncontrolled, semi-controlled and fully controlled. Now we will see the other type of classification. In this type of classification, we will see whether these switches are able to block the voltage or not. In this type, there are two types. First, unipolar switches. It means it can block only one type of polarity of voltage is if the other polarity of voltage falls across the switches, these devices or switches will turn on and conduct. For example, in case of diode, if nature of supply is such that this anode becomes forward bias, then the diode will turn on. But if supply reverses, that if anode becomes negative and cathode becomes positive, then the device will not. So it is blocking one type of polarity of voltage. Other example is transistor. Generally, the reverse blocking voltage of transistor is very less, so it can block only positive polarity of voltage. So if I see on the curve or graph VI curve, this is V, this is I, and this is for diode, then it can block negative voltage. But if I see the VI curve of transistor, it will block the positive voltage. Now other type of switches is bipolar switch. In this switch, it can block both type of polarity of voltage. That is either positive or negative, it will block both the voltage. Example, SCR. It will block both polarity of voltage. So if I see on the graph, this is voltage, this is current, then it will block both positive and negative. Okay, so this is the second type of classification. Now next move on to the next type of third type of classification. This is the third type of classification. In this classification, we will see whether the switches are unidirectional or bidirectional. It means it allows the flow of current through the devices only in one direction or both directions. So this is the first type where we will see that the switches under this type of classification will conduct only in one direction. Example, diode, transistor, SCR, GTO. It will, like suppose for diode, this is anode, cathode. It will allow the current flow through the anode and cathode, but not through the cathode to anode. Similarly, for the transistor, SCR and GTO also. If you see SCR, anode, cathode gate, it will allow the current through from anode to cathode, and not from cathode to anode. Hence, its name is unidirectional switch. Next type is bidirectional switch. It means if this type of switches will allow the current flow from both the directions. And the name is bidirectional. Example, track. Okay, we will see in detail. Now here we are going to see voltage and current characteristics of switches. So far what we have studied, okay, this thing we will study on the plot basis or graph basis. Okay, the first one is diode. So what will be it? We have characteristics. This will be, this is I. So diode can block negative voltage and it allows the current from anode to cathode in this direction only. Okay, so this is the IV characteristics of diode. Okay, and this type of questions has been asked in the GATE examination. You simply need to understand V means which type of voltage or which polarity of voltage it is able to block, and current means in which direction this current is flowing. Anode to cathode is positive current. Okay, so diode in this region it will operate. Okay, and this is the safe operating area also, because beyond this voltage, this is the breakdown voltage. Okay, if we are applying voltage more than this type of voltage, then the diode will break down and it will damage. Similarly, if we are applying the current more than this current value, then also it will get damaged due to heating. So this is our operating area, safe operating area. Next, SCR. Okay, this is gate. What would be its real characteristics? This is voltage, this is current. It can blow both polarity of voltage, okay, and it will allow the current flow through this direction, that is this. So this is its safe operating area, entire first and second quadrant. Okay, next, this is transistor. This collector. This is VGT. Drain, gate, collector, emitter. In this type of switches, the behavior characteristics is same. This is B, this is A. I told you that this transistor are able to block only one polarity of voltage, that is positive polarity of voltage. Okay, and it allows the current flow only in one direction. Okay, so this is the current. So what is its safe operating area? This is the first quadrant. So this is the IV characteristics of transistors. Okay, this is BJT, MOSFET, IGBT. Next is GTO. Okay, this is voltage, current. It can block both polarity of voltage, okay, because it's bipolar in nature, and it allows the current flow only in one direction. Okay, it has the added feature of that it can be turned off using the gate signal. Okay, that's why it is fully controlled switch. This is the entire area is safe operating area. Okay, so this is bipolar, unidirectional, fully controlled switch. Okay, so previous transistors, unipolar, unidirectional, fully controlled switch. Bipolar, unidirectional, semi-controlled switch. Unipolar, unidirectional, uncontrolled switch. Okay, now next, track. This is track symbol indication symbols. This is main terminal 1, main terminal 2. Here we don't use anode and cathode because the current flow from both the direction. Okay, it can flow from this direction as well as from this direction. Hence we show its terminal name is main terminal 1, main terminal 2, and not anode and cathode. This is the controlling terminal. This is voltage, current. It is bipolar, and not both polarity as well as bidirectional. Okay. And the entire 4 quadrant is same operating area. So it is bipolar, bidirectional, fully controlled switch. Okay. Now here we will be studying one important concept of body diode. In some of the power electronic devices like in MOSFET and IGBT, one parasitic diode is present. Diode means it's PN junction diode, which allows the current flow in the reverse direction, that is in the opposite direction as that of normal current flow direction in MOSFET and IGBT. Why this parasitic diode is present, it will be discussed when I will discuss the subject in detail. For the time being, just understand that in these two types of devices, parasitic diode is present, which takes the current or which allows the current flow in the opposite direction as that of normal current flow direction in MOSFET and IGBT. So how does it circuit equivalent will look like? This is diode, this is drain, source, gate. Okay, this is parasitic diode, what I am speaking about. Collector emitter here. This is the parasitic diode. Okay. So due to presence of this parasitic diode, its behavior character will change. How? See, polarity as that of before what I have told you, this comes under transistors, so it is unipolar in nature. Okay, that is, it can block only this polarity of voltage. If we apply reverse polarity like this here, due to this presence of this diode, it will not block, and this device also will not block this negative polarity of voltage. So it is unipolar in nature. Okay, and these devices, this one and this one, was previously allowing the current flow in this direction. Okay, but due to presence of this parasitic diode, it will also allow the current flow from source to drain, and in IGBT from emitter to collector. It will become bidirectional. So earlier it was unipolar unidirectional. Earlier unipolar and unidirectional. Now it is unipolar and bidirectional. It means if you are adding a parasitic diode, or if you are adding a diode in anti-parallel fashion to a device, it is not going to change its voltage blocking capability. It will only allow the current flow in the opposite direction. That is, if you are adding an anti-parallel diode to a device such as unipolar and unidirectional, it will convert the device into unipolar and bidirectional switch. Okay, so this is the concept related body diode. Now here we will see some previous year GATE questions. This question has been asked in GATE 2003. What it is asking? Figure shows the MOSFET with an integral body diode. See, in the question, if it is mentioned that a body diode or anti-parallel diode is present, then only you consider the importance of that diode. Like in case of MOSFET and IGBT, what I had discussed earlier, here we didn't consider any body diode, so we didn't take the importance of that body diode. But here we dedicatedly studied the body diode, so we have considered its importance. Likewise, in the question, if it is said to you or if it is given the body diode or anti-parallel diode, you consider its importance. So in this question, this body diode is given, so you have to consider its importance. It is employed as a power switching device in on and off state through appropriate control. The on and off state of switches are given on VDS I scale. So you have to draw this V and I characteristics. It is simple MOSFET with body diode. Just we have seen now. What we have seen, it is unipolar, okay, and it is bidirectional. That is, it will block only this polarity of voltage. If we give the reverse polarity like this way, it will not block, switch will not block, and also this device diode will also not block, because through this negative and positive it is getting forward bias and it will conduct. Okay, so it will block only one polarity of voltage, that is positive polarity of voltage, and it will allow the current flow from both directions. This direction current will flow through this switch, that is from MOSFET only, this one only, and this direction of current flow will take place through the body diode. So current in both directions, and voltage it will block only the positive voltage. That is, option B is the correct answer. Okay. Next, this type of question. This has been asked in GATE 2005. An electronic switch S is required to block voltage of either polarity during its off state, as shown in figure A. The switch is required to conduct only in one direction. Okay, in on state, as shown in the figure. See, in this question, what is given, that this switch is blocking both polarity of voltage. Okay, but it is allowing the current flow only in one direction. So you have to choose the correct answers. First time, see, this is one is SCR. Okay, so SCR we have seen its characteristics. It can block both polarity of voltage and it will flow only one direction of current. Okay, next, second option is BJT with anti-parallel diode, just like MOSFET. Okay, how its behavior characteristics will be, it will block only one polarity of voltage, but it will allow current flow in both the direction. Next, it is BJT in series with the diode. Okay, let us understand this one. This is one test. Okay, this is BJT. So BJT's property is that it will block only one polarity of voltage. That is, if we are applying this polarity of voltage, it will be blocked by this BJT. It will be blocked by BJT. Okay, but it will not block by this diode. Okay, anyway, if overall we are considering this as a switch, then this positive polarity of voltage will be blocked. Okay, so this positive polarity of voltage is blocked. Next, if we apply negative polarity of voltage, okay, So this negative polarity of voltage will be blocked by the diode, but this BJT will not block. Okay, so overall as a switch, negative polarity of voltage will also block because these two switches are in series. If any one of these switches is blocking the voltage, then the overall the switch will block that voltage. So also the negative polarity of voltage is being blocked. Now comes the current direction. This BJT is allowing the current in this direction, and diode is also allowing the current in this direction. Okay, so current is flowing from 1 to 1 dash, that is in this direction, but the reverse current will be blocked by this diode as well as this switches. So it will allow the current flow only in one direction. This one, fourth one, it is same as that of this previous arrangement, but one body diode is also present here. Okay, let us draw it clearly. You see here only in this option. Okay, due to presence of this anti-parallel diode or the body diode, it will not block the reverse polarity voltage. That is, it will block only one polarity of voltage, and it will allow the current flow in both the direction. This positive direction of current through this device, that is BJT and diode, and negative current from anti-parallel diode, but it will not block the negative voltage. So what is the question that has been asked here? It is asking it will block the both polarity of voltage, okay, and only one direction, that is this SCR and this arrangement. That is option 1 and 3 both are correct. Actually these options, I think it has been missed here. In the given option you will be given like option 1 and 2, 1 and 3, option 3 only kind of thing will be given to you. So among that option you need to select the option which contain 1 and 3. So correct option is 1 and 3. Next question, this has been asked in GATE 2009. Match the switch arrangement on the top row to be steady state VI characteristics on the lower row. Okay, here the switches has been given and corresponding VI characteristics is given. You have to match. First one is diode. Diode blocks negative voltage and positive current, that is negative voltage and positive current. This is for diode. Second is SCR. SCR will block both polarity of voltage and only one direction of current. Both polarity of only one direction of current. This is SCR. This is IGBT. IGBT will block only one polarity of voltage, that is positive polarity of voltage, and it will allow the current flow in one direction, that is unipolar and unidirectional. So this is C, and this remains D. Anyway, let us discuss this. So this is your IGBT with anti-parallel diode. So if anti-parallel diode is added to IGBT or MOSFET, it will convert into bidirectional, but it will remain unipolar. That is D here, bidirectional unipolar. What is the correct option? A4, B3, C1, D2. So option C is the correct answer. Now you can see the label of question here. Only you need to understand the concept. If you know the concept, then you can easily and quickly answer this type of question. Okay. Next question. This has been asked in GATE 10. Figure shows the composite switch consisting of power transistor in series with a diode. Assume that the transistor switch and diode are ideal, the IV characteristics. Okay, it is BJT in series with a diode. Just now I have explained. Let us explain it one more time. First I will discuss the voltage blocking polarity. If positive voltage is applied, then this BJT will block because of unipolar in nature. Okay, the positive polarity of voltage is being blocked by BJT, that is overall switch will block. If we apply negative voltage, so this voltage will be blocked by diode. but it will not be blocked by this BJT. So overall this switch will block the negative voltage. Okay, now see the current flow. If I see the current flow in this direction, then if this current will be allowed by this BJT as well as this diode. Current flow through this diode positive and entering. Here the question, the current I is entering in the anode, that's why I have shown, and this current direction is same as the current direction here that we have seen, we have considered. If we see the current direction in this way, then this current will not be allowed by this diode as well as the BJT. So only one direction of current. So out of the given option, which one is the correct option? Option C. Now you can see the level of question. You can easily solve. Once you get the concept, you can easily solve. This is the last question for today. Figure shows 4 electronic switches 1, 2, 3 and 4. Which of the switches can block voltage of either polarity? That it should block both polarity of voltage. Apply between terminal 1 and B, A and B, A and B. When the active device is in off state. Okay, you need to select the options of the switches which will block the voltage of either polarity. First of all, you need to see 1 and 4 both are having anti-parallel diode. So whenever anti-parallel diode is there, it will not block this voltage, because whenever this voltage is applied upon the switch, this diode will allow it, diode will turn on and starts conducting. So these two options are eliminated because it will not block this negative polarity of voltage. Now see option 3. In option 3 it is SCR, and SCR it is bipolar in nature, so it will block both polarity of voltage. So this is okay, it will block. Next, this will not block, this will not block. This question, this is IGBT in series with a diode. So IGBT same as BJT what we have seen now. This is A, this is B. Okay, if we apply positive voltage, it will be blocked by the IGBT itself. However, diode will not block, but overall as a switch it will block. Okay, now if we apply negative voltage, this negative voltage will be blocked by this diode, but this will not block with the IGBT, but overall as well it will block the negative voltage also. So this switch IGBT in series with the diode, it is blocking both polarity of voltage, and that has been asked in the question only. Which of the following switches can block voltage of either polarity? So out of the given option, correct option is option 2 and 3, that is option C. So that's all for today. Okay, now you can see the level of question which has been asked in the previous GATE examination. What you need to know is the concept, and that to be very simple. That's why I told you in the beginning, it is very simple but very interesting as well as very important for the GATE examination. Okay, thank you. Thanks for the watching.